Maybe you can help me with the calculations. Another static equilibrium problem, question 16. Not a trivial one. So it's a 60 centimeter rod, which means that this distance here is 40 centimeters, and which means the distance from the tool to this one is also 20. So we're trying to find shelf and static equilibrium, very small, 20 Newton, 25 Newton tool is placed on the shelf. Find the tension in the rightmost wire, so this wire. So if I think about the shelf and what forces are on it, there is a tension force here by the leftmost wire. There is a normal force by the tool. There is a weight force right smack here in the middle, mg, and then there's another tension force here as well. Tension right and tension left. So if I wanted to solve for the tension right, the place to put the pivot is at tension left because I don't know anything about the left tension. So that's the appropriate pivot point. So about that pivot point, the tool wants to rotate the shelf clockwise. The weight wants to rotate it clockwise. The tension right has to balance those two clockwise torques. So the torque T right has to be equal to the torque of the normal by the tool plus the torque of mg. So the tension right would be the tension, so there's no angles here, which is nice, times 0.4 meters. So it's 0.4 meters from my left end is where the tension force in the right acts. The tool is going to be, so it's 25 newtons, so I don't need to convert by g, so this is not a mass, it's a weight force. Technically, it's the normal will be equal to its weight. And if it's exactly halfway between the two wires, that means it's also 20 centimeters, so 0.2 meters from the left end. And then the weight force is a 50 Newton weight times 0.3 meters, since it's a 60 centimeter rod. So the tension would be equal to, so that's 1/5 of this is 5 Newton meters. 3% of this, 1%, 10% is 15 Newton meters. Divided by 0.4 meters. 20 Newton meters divided by 0.4 meters, 50 newtons. All right.